Hi everyone, my name is Shinpei Kato. The headline of my presentation today is the open source journey towards intelligent vehicles for everyone. I'm a founder and a CTO of Tier IV. We're based in Japan. I also chair the Autoware Foundation, which is a non-profit organization where we maintain open source startup project called Autoware. I also work at the University of Tokyo, and I serve as an associate professor. This video shows our robotaxi project that we launched last year. As you can see, this robotaxi is operated without any human drivers. We are qualified to operate such a driverless robotaxi on a public road, satisfying the requirements and regulation defined in the government. Now we started operating multiple robotaxis in different locations. We believe that this is a big step towards the real services of robotaxi in the future. This is another example that we developed with Yamaha Motors. This small car is already deployed in factories operating 24 hours every day. All of our solutions are based on open source software called Autoware. When you download this Autoware, you have the whole capabilities that are required to build autonomous vehicles. For example, it provides perception and localization, planning, and control modules, including the interfaces for the sensors and vehicles. Now, Autoware is an open source project, while Tier IV is a startup to deploy Autoware into the real business. So I'm going to introduce how Tier IV utilizes Autoware. The product that Tier IV offers is Pilot.auto. This includes Autoware with the reference autonomous driving kit. Using Autoware, Pilot.auto also provides the set of sensors and tools for the developers and customers to test, verify, validate, and operate autonomous driving services. So when you installed Autoware, the vehicle has a set of sensors. The most deployed sensors today is a camera. In addition to the camera, Autoware also uses a LiDAR, which can scan the environment around yourself, including 3D structures of the environment. And having multiple different sensors, including cameras and LiDARs, we also use 3D map and high-definition information on defining the features of the road. So thanks to the 3D map and high-definition information about the features of the road, you don't have to recognize, for example, the static information such as the lanes. So as far as you localize your position, you can reference this 3D map information, recognize the position of the lanes. Having 3D map and a set of sensors, now you deploy multiple algorithms such as deep learning. So using the sensors and algorithms, you can detect objects around yourself, and the detected object can also be predicted in a way that how they move. Using the result of this prediction, we can make the plan or the behavior for the autonomous vehicle. In this case, for example, the detected vehicle in front of yourself is not moving. So you have to stop. Such a planning of the vehicle behavior, it can be reflected, the result of the behavior can be reflected into the control module of the vehicle. The Autoware computes this computation. Autoware computes these modules in real time. Every frame the sensor input the data, it runs localization, perception, planning, and control modules. As you can see, so this is how Autoware-based autonomous vehicle recognizes the real world, localizing the position of the vehicle, recognizing objects around the vehicle, and making a plan in real time and reflect it into the control module. On one hand, Autoware is used to provide reference autonomous driving kit. Tier IV also provides a service platform called Web.Auto, which offers the tools for developers and customers. The tools for developers include simulation, while those for the customers include fleet management. So I introduced a couple of examples that included in the Web.Auto toolchain. So when you want to make a test scenarios, you can use our scenario editor. This is also published in part as an open source project, and we also deployed on Tier IV's cloud service. So you can just access our cloud service and load 3D map data, which is correspond to the scenarios that you want to test. And once you load a 3D map, you can start creating the scenarios for the test. In this case, from one intersection to another intersection, you have an ego vehicle and another vehicle in between the intersection, and you can test if your autonomous vehicle can successfully stop or avoid. And you can create many numbers of scenarios and register them onto the dashboard of our service platform, so that every time you compile and build the system, the scenarios registered in our platform always tested. So one of the scenarios that we often test is in its intersection. So this is a case for making a right turn, and in intersection we have multiple vehicles approaching the intersection. You can see that the test successfully passed where the vehicle detects the vehicles and the objects in the intersection and successfully stop. For the customers who want to use Autoware for real services, so we provide the tools and platforms which is useful to ensure the safety of operation. The examples include remote monitoring. So Autoware-based vehicle has an interface that can be connected to a remote server, and in the call center, for example, they can introduce this remote monitoring system and can always watch out if the operation of the vehicle is safe. So we are working with insurance company in Japan. They actually use this remote monitoring system alongside the 5G networks. So even for field tests, so our robot taxi vehicles are monitored by human operators, and if some accident happens, we can call in the vehicle and can even talk to the passengers and see if they're safe. We believe that autonomous driving, so to make it realize in a real service, not only the technology component but also the service component are essential to be tightly coupled. So Tier IV wants to provide autonomous driving kit, which is based on Autoware, including technology components, but we also want to provide the service platforms that correspond to our autonomous driving kit. And in the end, having such service platform, when Autoware-based vehicles go into real services, we can use our fleet management system to see the status of the vehicles, and if some system accident or failure happens, you can check from the remote so that you can, for example, change the hardware, or you can make it maintenance mode. So Tier IV is a full stack company providing technology components and service components. And we also respect the definition of operational design domain. So in order to deploy autonomous vehicles in real services, you have to strictly define the condition which is expected by autonomous vehicles, and if that condition does not hold, you should stop the operation. So to that end, Tier IV's autonomous driving kit, including technology components and service platform, offering the tools for developers and customers, will be useful contributions to make it happen. And now we are operating autonomous driving services not only in Japan but also in various areas in around the world. This, thanks to the Autoware Foundation, we can reach out many partners and customers through the open source community. To deploy autonomous driving technology in real services, it is important to define the operation design domain that represents the condition that is expected to be operated by the autonomous vehicle. Now we're expanding this operation design domain from Japan to more global environments, and Taiwan is one of the most significant strategic partners for us. We have many members from Taiwan from Autoware standpoint, and we appreciate their great contributions so far. We hope to keep this momentum and welcome more members from Taiwan who are interested in participating in the open source journey together. Thank you.